All right, so today we'll be going over the second method of graphing a parabola, which is by completing the square. And the point of completing the square is to get your equation that you see here in the form a times x minus h squared plus k. And when you have this form, we call it the vertex form, and we can identify the vertex h comma k, which is arguably the vertex is probably the most important point on the parabola. That's where it opens up or down. And there's other advantages of writing your parabola in this form right here. Okay, now let's go ahead and get started on that. So the way we get that equation to that equal 4x squared plus 3x minus 7, excuse me, to what you see there in blue, is by doing the following. The first step is you want to isolate the x squared and the x term that are on the right hand side. So I'm going to add 7 to both sides. So let me actually just erase all of this. I'll get back to that. So I'll add 7 to both sides, and right when you add 7 on the right hand side, the 7 goes away. I have nothing left. Okay, step number 2. You're going to go ahead and factor out the coefficient of x squared from both the x squared term and the x term. So our coefficient is 4 in this case, so we're going to factor 4 out. And yeah, we're going to have a little parentheses there. And what's our result? Well, 4 divided by 4 is 1, so you have 1x squared. And 3 divided by 4 is just 3/4. The tendency that I've seen people write down is that they'll write down 0.75 or a decimal. I recommend you don't do that. It's just, we're going to do some computations, and it just gets more difficult if you do that, in my opinion. Okay, so it's really up to you, but in my opinion, I wouldn't go ahead. I would go ahead and keep it as a fraction. All right, so I just erased that 1 from the x squared there, because 1 times x squared is like saying x squared. All right, so the next step is as follows. You're going to take the coefficient of x, which is the 3/4, and it's always the case. The coefficient of x, whatever that might be, divided by 2. Always divide by 2. However, since we're working with fractions, dividing by 2 is like multiplying by a half, so it's 3/8. This is what your result would be. And what we'll do is as follows. We're going to take that 3/8, and we're going to go ahead and add 3/8 squared to the x squared and the 3/4 x, like I did right now. However, I have to add something else to the other side. If you just do one side and you don't do the other, it's no longer an equation. What is it that I add? I'm not going to add just 3/8, but I'm going to add 4 times 3/8 squared. You always add this number times that number, because at the end of the day, that's really what we're adding to this equation. Yeah, the way to check all your work here is to distribute the 4 back here, and there as well. I'm sorry. And yeah, you would have an extra term of 4 to the 4 times 3/8 squared. Okay, so I have to add that to the other side. And one more thing I wanted to mention is, yeah, at the end of the day, all we're doing is just rewriting the original equation in a new form. I'm not actually adding anything different, the number to it. Now, on the left-hand side, I'm going to do a little bit of arithmetic. 3/8 squared is 9/64. And we'll just go ahead and keep the right-hand side the same. I'm going to do anything with that. I'm going to do cross-canceling. 4 goes into 64 16 times. And I'm going to add the 7 and the 9/16. Need a common denominator, which is 16. Multiply the top and the bottom by that. And this is 112/16 plus 9/16, which comes out to be 121/16. And on the right-hand side with all these steps, you would have the same expression that I have up here with the 4 times x squared plus 3/4 x. That would not change. Okay, so I'm just going to bring all that down. this expression right here, once you add the 3/8 squared, it becomes a perfect square trinomial, which means that those three terms, that trinomial, is equal to saying x plus some number squared. And that number in this case is the 3/8. It's always plus the number that the coefficient of x that you divided by 2. So we took the 3/4. Sorry, let me rephrase that. It's the result of the coefficient of x that you divided by 2. So 3/4 divided by 2 was 3/8. That is what you just put there. And yeah, and the reason I kept the 3/8 squared, by the way, is so that's a reminder that always happens. We could have, that's 9/64, and I could have just added 9/64 there, but I rather kept it that way. And then on this side, I have y plus 121/16. And pretty much we're there. We've got one more step, which is subtracting the 121/16 on both sides. And arguably, this is, well, not argue, it is in that vertex form. And what I meant to say is that arguably the vertex itself is the most important point here on a parabola. In our case, the vertex would be -3/8 minus 121/16. Okay, and that's where it opens up or down. Okay, all right. So we have the vertex. A couple other pieces of information that I like to get from this, which is whether it opens up or down. Since the coefficient of x squared was 4, the original equation, that's how you know it opens up, because 4 is positive, okay? Now, the next couple pieces of information, or the next one, excuse me, if I had not worked with with completing the square, then this next part would not be so simple. Excuse me, I meant to say x-intercepts. Yes, what I'm writing down, right, is finding the x-intercepts is what I'd like to do next. If you watch the first part of how to graph a parabola, I talked about finding the x-intercepts, but I said when you don't have this expression, which we have here in that vertex form, it's harder to get the x-intercepts. You can get them, you can use a quadratic formula and such, but they're not always easy to get. So for the x-intercepts, the way you do that is by setting y equal to 0, because the x-intercept just means where the graph crosses the x-axis, and the x-axis y is 0. So you would have 4 times x plus 3/8 squared minus 121/16 here. And what I'm going to do here is as follows. I'm going to go ahead and solve this equation by isolating the part with the x. So I'm going to start by adding 121/16. Divide by 4. And then I'm going to take the square root of both sides, which is 11/8, plus or minus. Okay, so we use the square root property here. And you'd have two solutions. X plus 3/8 equals 11/8, and then x plus 3/8 equals minus 11/8. Excuse me, two solutions from two equations. If you solve the first one, you get 1, and if you solve the second one, you get minus 14/8, which is minus 7/4. And you would have also a y-intercept, and the y-intercept is fairly easy. All you have to do is replace the x with 0, and you can just go back to the original equation. In this case, you would get -7. And this would be 0, -7, and for my x-intercepts, you write them up points, be 1, 0, and minus 7, 4, 0. And we can now graph our parabola with all this information. I mean, you could do it with the vertex and maybe one of the the y-intercept, but you get an okay graph, not very detailed. So I'm going to go ahead and plot all this stuff down here. So 0, -7, 1, 2, 3, 4, 5, 6, 7 would be here. Minus 1, or sorry, 1, 0 would be here. -7/4 is -1 3/4, so that's like over here. And then our vertex, which was minus 3/8, negative 121 over 16. So the minus 3/8 is, yeah, it's negative, and then it's a little, 121 over 16 is a little below 7. It's like 7 and some change here. So that'll be here. And when we graph this, we'll get this graph right here. Okay. And there we go. Okay. And that is the sketch of this parabola. Now you might have found this all very tedious. Again, I wouldn't disagree with you, but there's advantages of completing the square, and I mean, obviously finding the x-intercept, the vertex as well. That's one thing, because with the other method was negative b over 2a, f of minus b over 2a, and that was rather tedious in terms of the computations. Yeah, I mean, there's computation either way you look at it, but the advantage, for me, the overall advantage is that you get to practice completing the square. And for many of you that are in other classes, trigonometry, college algebra, or if you're going on to calculus or whatnot, you're gonna have to learn how to complete the square somewhere. So it's good practice to work on that. All right, well, thanks for your time.